Alright, so I just want to take a little bit of time today to go over a couple more things with vectors that may help you out with your homework. So the first thing that I want to go over is when we have a series of vectors and we want to write one of them in terms of the other. Okay, so let's look at this first example, which says let's write t in terms of the other vectors. So here I've got a triangle that has r and s and t. Now t starts at this point and then it goes to the right and ends right there. Now I know the starting and ending points because, as I'm supposed to, I drew t as an arrow. Remember, the arrowhead shows the direction and the length shows the magnitude. So I start here at the tail and I go to the end. Now how can I use r and s to represent that t? Well, I have to start at this point right here. So I start here, and then where do I go? Well, first I follow r, which means I need to take vector r. And then when I get to the end of r, I'm then going to follow s. So it'll just be r plus s. Now that should make sense because if you look at r and s, they're being added head to tail. And since they're being added head to tail, that means that the resultant will start at the beginning and end at the end. And so you can visualize how those two are being added together to result in starting here and ending at the end of t. Alright, so let's look at one that's a little bit different. Write s in terms of the other vectors. So this time, we're going to be starting right here at the beginning of s. And so we're going to be starting at s, and we want to end up down here. Now, by following the other vectors, the only way to get there is to start here and go backwards through r. Now, going backwards through r is going to result in a negative r, because that means we're going in the same direction except 180 degrees in the opposite direction. Same magnitude, it's just exactly the opposite direction. So we'll go down here, we end up there. Now we need to follow along t, and note that t is in the correct direction. So it'll be negative r plus t. Now, we learned in the lab in class that it doesn't matter which order we do these in. You could have actually done t first and then done r. So let me see if I can just draw this in here to help you visualize that. If we were to take t, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, about 13 and a half squares, that would go like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so about right there. That would be t. Oops. So we take t first, and then we would go down this way, which would be negative r, right? That's exactly what r is, just in the opposite direction. And you'll note that we end up in the same place. We still result in getting s. So it doesn't matter whether you do negative r plus t or t plus negative r. Now you'll notice on all of these I'm putting the little vector on top. You should do this as well. The little vector on top shows that we are working with vectors, not with scalars. That's why you've never had to write them before, because usually you've been working with scalar numbers for your whole entire life. And so now that we're adding in vectors and direction, you need to add that. Now in the book, sometimes, not just in the book, but elsewhere, sometimes it will just resemble it with a bold variable. And so the bold also means that it's a vector. Now, a third way that you can see that is what we're going to see in our next question, right here. Right here it shows us st. That's because st doesn't have a specific name on the side, and so we just name it by starting at its starting point and ending at its ending point. Please note that it does have the arrowhead showing that it starts at s and ends at t. But even if it didn't, we would be able to get that from the statement here, because the arrow starts at s and then ends in the direction of t. So that tells us that it's going to go in this direction. And now we want to write that in terms of a, b, and c. Well, s starts here at s and it ends here at t. And so that's what we need to do, is make sure that we follow through these a, b, and c and end up at t. Well, I can't go this way right here because that's going to be going along a vector that I don't know what it is in terms of a, b, and c. Well, kind of do, but it's not really helpful at this point. So I'm going to start at s, I'm going to go back to q. Now note that that's going backwards along b. And so my first one is going to be negative b. Okay, so I go back along here. Now I'm at q. Now at q, I need to get to t. And so I'm just going to follow along c. I'm starting at its tail. I'm going in the direction it's supposed to be going, in the magnitude that it's supposed to be going. And so therefore it will be negative b plus, what just happened? Okay, this whole touchscreen thing is driving me crazy. So negative b plus c. All right, and so that will be the correct answer for ST. Now let's go ahead and look at one more because we didn't have a chance to talk about multiplication in class. So I just wanted to go over that really quick so that you've got it. All right, so here we go. Find 2v minus 1 half w. Now multiplication of vectors is very easy graphically because just like with any other variable, when you had back in Algebra 1 or pre-algebra, when you had 2x, that just meant that you had x plus x, right? So this is really the same thing as v plus v. That's what 2v means, right? It means there's two of them being added together. And so visually, you can just take it. It looks like it's 4 diagonally, which is about 4 root 2. So I just need to take two of them. So I'll go 1 v and then 2 v's. Okay, so that's v plus v, which is 2v. So this right here, whole thing is 2v. And now I want to subtract 1 half w. Okay, now w should be going down. It's got 1, 2, 3, 4, 5, 6, 7, 8. So 8 squares down. Now I want to subtract, which means it needs to be going the opposite direction. So instead of down, it's going to go up. And I only want half of w. And so instead of 8 squares, it's just going to be 4. So I'm going to start right here. I'm going to go 1, 2, 3, 4. So right there, that is negative 1 half w. That was easy, right? Now, please remember that you should always draw in your final resultant vector, which starts where you started and ends at the very end. Okay? Now, I'm not using a ruler, but I probably should. The reason I'm not is because the ruler messes up with my touch screen, and I'm too lazy to go in here. Okay, yeah, I guess I should probably do this. We'll go ahead and open this up. We'll start here, and then we'll end right there. See, that's what it should look like. All right, so there you go. There's the resultant vector of 2v minus 1 half w. I hope that's helpful for your homework tonight, and I'll see you soon. Or maybe not.